Okay, today our discussion will be about parabolas, and we're going to do the specifics of parabolas because we're in a section called conic sections. So we're going to actually show where they come from and a little more than just y equals ax squared plus bx plus c, which is what we did before. So you can see from our learning goals where you want to be able to write and graph the standard equation of a parabola given sufficient information, and then also given an equation, be able to label all the different parts of the parabola. So to do that, let's first introduce us to our definition of parabola. A little different than we saw before. Parabola is a set of points, P, we're calling them. They're all xy ordered pairs that are equidistant from a point called the focus and a line called the directrix. So if you can think of that point that's the focus and the directrix, all these other points will lie so that you can see their distances. So right now, if we looked at what we had, our point P is equidistant in two directions to this line called the directrix, and so any point that is along here would also at some point have to have that equidistant look from that point on the line or some point on the line and back to that focus point. So if we look at that, then you should be able to tell me right now, and the easy one is the one we worked with before, and that was we know the vertex of a parabola is that lowest or highest point, the min or the maximum, and so we would say that that blue point here is our vertex. So that means that focus is that point. That's an equidistant point. And the directrix is that line, also equidistant. So keep in mind that there is an equal distance involved. And so when we look at this, you know, there's also that equidistant characteristic right here in the middle. Okay? So if we know our distance between the focus and the vertex, then we know our distance from vertex to directrix. And we just did distance formula in that last section, so we should be good to go, good to find things. But I do have a little applet that I pulled off of the internet that shows how these things are made and how that equidistant thing works. So let's see if we can get it to work for us now. Here is that same, by definition, okay, same picture. But if we now bring this down, drag the red point to make sure PF and PH are equal. The distance in the focus and the directrix, so changes what shape of the parabola does it become. So right now, we're going to say we have this point of, and watch as the parabola is drawn. What is happening about that equidistant piece that we described, and see what happens to our parabola. Okay, so watch. You already have the line, the directrix, and then the focus. Okay, now let's reset it. Let's make it a little different. Okay, let's make it, no, let's make it small. Whoa, let's reset that. Okay, so let's go, it was right in the middle. Drag this down a little. So watch what happens now with our parabola. It is so tight, that focus to the vertex distance and that vertex to the directrix distance. We have a tall, skinny parabola. Reset it again. And let's move that a little. And now, finding our focus and directrix, drawing our parabola. See how that works? So interesting, as we move the different features, we can get this parabola drawn, keeping the focus, directrix, and vertex all in play there. And that's how we get the different steepnesses on our parabola. So back to our work. If that's a situation, then we want to talk about, well, there has to be a little information that you can give us about this setup. And here it is. Here is that again, focus, directrix, equidistant combination that we had talked about. Okay? So our parabola drawn in red, and our focus is there, our directrix is parallel, and we have the parabola being drawn. Now, the horizontal, because this has been our normal situation, horizontal directrix, most of our parabolas have opened up or down, and that is normal to us, so take a look. Normal means we've got y equals x squared. Those two pieces are very normal to us. But now we're going to talk about if we have this horizontal directrix, which means we have a horizontal line, our parabola either has to open up or down. So it does mirror what we've been working with. But notice that a value, we always called what determines the steepness, is now a fraction 1 divided by 4p. If p is greater than 0, so if p is positive, it opens upward. If p is negative, it opens downward. So that still tells us whether this thing will open up or down. The focus is at the value 0p. So if we know that p value, which is that distance we're talking about, the focus from our vertex, that 0p is where the focus is at. So this, think of it, is that p value. The directrix is y equals the opposite of p. So if we're at 0p for our focus, then this has to be, in the opposite direction, negative p. Okay? So whatever that p value is, this is, if this is 3, then this is going negative 3 in the opposite direction, because we know the blue dot is 0, 0. That axis of symmetry is still the y-axis because we're focused right around it, and we're going to keep it easy here for a while. We're not going to translate our combinations. So horizontally, still looks normal. Y equals, yes, our equation ax squared was before. Now you just have to think 1 over 4p. 1/4 times p is another way to think of it. Okay? So knowing that, we're heading to the vertex, the vertical directrix. Okay, so if we turned and had a vertical directrix, which now means our whole picture of things turns sideways, we just have a little different perspective or orientation. Now, we have not been calling these parabolas until now. So be careful in switching your perspective. Here we go. If before we had a y equals equation and our parabola went up or down, we now have to have x equals. So if we were comparing it to an old form, we'd have x equals ay squared, or whatever you want to say, whatever you want for your variable. So there's my parabola in red. You have your point that's at the origin. Okay, so your blue value we know is 0, 0. Okay, we're not moving these away from 0, 0. We're trying to stay nice for you. We have the same situation. We have a point anywhere on my parabola would be a point that is equidistant to that directrix and that focus. And that's where these points from the parabola are coming from. So knowing that, again, we know that that p-value indicates that distance. And as that p-value gets bigger between the origin and the focus, okay, so our p-value, and then if we went from here, that would be the opposite of p. So, looking at our characteristics, when p is greater than 0, it'll open to the right. So when p is positive, think of it that way, and p is negative, it'll open to the left. Your focus is no longer above the x-axis. It is now to the right of the y-axis. So we get the point p, 0. If it opens to the right, that is. If it opens to the left, it's going to be in the negative range. The directrix will be x equals the opposite of p. So if your focus was on the right side of the x-axis or on the right side of 0, 0, then your directrix is on the left. If your focus is on the left, your directrix is on the right when we're centered at 0, 0. Okay? So the axis of symmetry goes through the vertex. It always has when we're centered at 0, 0. So here's our axis of symmetry. What I have. Okay? And it divides the parabola into two equal pieces. We knew that, talked about that before when we were in 2 dimensions. So the axis of symmetry also contains the focus, and it is perpendicular, so here's the focus again, and it is perpendicular to the directrix. So we know right here we have that 90-degree angle. The vertex of the parabola is the midpoint between the focus and the directrix. So if you know the focus, you know the directrix, you can do the midpoint formula to find your vertex. You might know more information, so maybe you just have to cut, you might know a p-value, so then you just have to do your subtraction, addition, whatever. All right, so you're going to be given equations in this form, and you're going to be asked, what's the vertex, what's the directrix, what's the axis of symmetry, right? And I believe that's where we're headed next. So here's an example. If I said graph this equation, that's great, but before you graph, you should be able to identify different parts of this. So from this, a couple things you need to recognize right away is that we have an x equals equation. And if we have an x equals equation, then we know we have that vertical directrix. Okay, so this thing opens left or right. So you start looking at it and said, okay, I know the regular equation is 1/4 p. And this one says it's just 1/4. So you should be able to say that p was 1. And if p is 1, then that allows you to identify several things. Identify the vertex. If we were at, we are at the origin because of our equation. So we would have the vertex is at 0, 0. We have a positive value, so we know that this is opening to the right. If it opens to the right and we have a p-value of 1, our focus has to be at 1, 0. So maybe we'll just do this and put them above it so we keep track. Okay, so we got our vertex and we got our focus identified. And so if the 0, 0, the 1, 0, the p-value is 1, we got to go the directrix in the other direction, so we know that would have to be a -1 for our vertical line. and any point on that vertical line would be a point on the directrix. Okay, so to start, it says use our table of values to sketch, but let's sketch some of the stuff we already know. So we know our vertex is 0, 0. Whoa, let's lock that down. Okay, this one's going to be awfully tight. I probably should have used a smaller font. Our focus is 1, 0, and we were always putting that in red, so let's continue to do that. Our focus is at 1, 0, and the directrix is at -1. We were using solid line there at -1. Okay, so our parabola will not touch the directrix. It will not touch the focus, but it'll be more orange points that we will use and get from our table. So here we go. We have our equation there. If we put a -4 in and squared it, we would get 16. A fourth of 16 is 4. Put -2 in, square it, you get you get 4, and a fourth of 4 is 1. Put a 0 in, we would get 0. Put a 2 in, we would get 4. A fourth of 4 is 1. Put a 4 in, we get 16. A fourth of 16 is 4. So we have our other values we can use. So here we go. When x is 4, y is -4. Now you'll notice that it was easier to put these y values in. So I have them on top as if they were our input. And then I have the output, which is x, or the answer. But when you graph them, you still have to graph them as x, y. So be careful and you don't do it backwards. So I'm going to go over 4 and down 4. 1, 2, 3, 4. Draw a point. I'm going to go to 1, -2. I'm going to go to 0, 0. I'm going, whoops, yep. Then I'm going to 1, 2, and then 4, 4. And using the orange points, you can see that is the look of our parabola. So with a smooth curve as possible, try to get our parabola look there. Put your arrows on the ends, and you can see that we have a parabola that opens to the right. We have our focus equidistant from the vertex, and our vertex that same distance to the directrix. There's our graph. Good enough? Moving on. Write the standard form of an equation of the parabola with its vertex at the origin and the directrix y equals -6. Now, it is a good idea to draw, sketch in your mind anything that would help picture the situation. It doesn't have to be a perfect graph, just a sketch is good. But obviously our final goal is to write the equation in standard form. All right, so let's take the information they've given us. All right, let's start with our axes. So my sketch is going to be quick, and we have some information here. The directrix, so the directrix is y equals -6. So it's a horizontal, so it's fairly normal. And I know that's y equals -6, so I label it. With its vertex at the origin, so we're going to put our vertex in orange. And then lastly, we're looking for our focus and our p-value, so we can write our equation. And actually, you don't even need your focus because they only want your equation. So if you're saying, hey, it's a parabola that's based on the origin, then you know you either have an x equals 1/4 p y squared, or you have y equals 1/4 p x squared. It's either left or right, up or down. So those are your only choices. So right now we know it's up or down because we have a horizontal, and so with that we can eliminate that. We know we need that p-value. Actually, we have enough information for that p-value because this p-value is equidistant to our focus, which would be up there. So our p-value is actually, 6, not negative 6. The directrix is negative 6. So we can then put that 6 in, and y equals 4 times 6 is 24, 1/4 x squared. There is our equation for our standard form going through the 0, going through the origin, parabola to this situation. There we go, they match. Okay, now I believe day 2 information we'll be spending on these starts going through the transformations. Now, the transformations are not totally different than the transformations we've been doing in the past, meaning I've got the HK values, what it affects it, but look carefully because we do have some differences. Horizontal directrix. We will still have y equals. It'll still lead off with a y equals equation and our x squared. So it's still mimicking our y equals x squared if it's going up or down and still has been moved. Okay, that's not really going to change anything. But notice we still have the 1/4 p is that constant out front. We still have the hk value. So if we moved this thing from the origin, now here is, let's do it in a different color. Here is that old position at 0, 0. That's our old position. So we still know if p is positive, it'll open upward. If p is negative, it opens downward. That did not change. We now know that our focus, well actually let's start with, if this thing has moved and it's gone over to the right and up in this case, it has moved our hk, which we've talked about. So our vertex is now hk. If our vertex is hk, then we know our focus has to be p units from the vertex, and our directrix has to be p units in the opposite direction from the vertex. Since our focus is on the same line, vertical line as our vertex, it's on an h value. So you're seeing h, and then whatever our k value was, plus that p value for the focus. And then our directrix is a horizontal line. We know all horizontal lines are y equals, but it's y equals the k value we were at, take away that p, that distance, because plus p got us to the focus, minus p has to get us to the directrix. So that's the difference there. And then the only other thing, remember that when you slid this parabola over and you got a new vertex of hk, that now means the axis of symmetry is also new. So our axis of symmetry is x equals h, that black dotted line. So same thing would happen in the vertical situation. It's just a lot to digest at once. So again, excuse me, there's our origin 0, 0. Okay, so however we've moved this thing to its new resting spot, it's been a hk movement for our vertex. Okay, so our vertex is hk. And if it's on a vertical directrix situation, again, that p-value is at equidistant between between the h value and the directrix, the h value, and the focus. From there, you need to realize that your axis of symmetry also has changed. It used to be right through the x-axis. Well, if we move this thing hk, k units up, it is now a horizontal line through that k value. So looking good there. We'll see what happens as we go forward now. I would like you to write these two down and see if you can just identify the key pieces from these new equations. So you've got 1 y equals and you've got 1 x equals. If you want to, because you notice the different part there, you could bring that 5 back over and look at it in the same way that we had on our last slide, or you could leave it as is, because that's been the form we've been using for transformation, and then identify the vertex, the axis of symmetry. How does it open, up or down, left or right? Where's the focus? Where's the directrix? Just by looking at the equation, you should be able to get those. So if you write those two down and jot down what you believe are those elements, then we should be able to talk about those when we come to class. So next, if they ask you, and this will be in day 2's work, to graph the parabola, and you start looking at this equation and it's loaded, -1/4 y squared minus y plus x minus 2. It's not even in the form that we're looking for, because we want it to be x equals, y equals with our quantities, especially if it's been transformed, and we're going to assume that these are transformed. So in this case right now, this one's probably going to read x equals, or x minus h equals 1 over 4p times y minus k, the quantity squared. It doesn't look anything like that. So to me, it looks like we need to complete the square. So we need to get this thing in the right form. So step 1, isolate the y terms. Why the y? Because they're the squared. They're the quadratic. From there, once you do that, multiply and really isolate the y terms. You need an a value of 1. So we multiplied everything through by a -4. From there, we completed the square. You can see that the value that we added to both sides, the new missing piece, was that 4. To complete the square on the left-hand side means you should be able to write it as a perfect square. And as soon as you write it as a perfect square, you can simplify and factor the right side, so we get a parenthesis over there as well. We're getting closer and closer. We need now information that'll get us to our correct form, which needs to be that 1/4 p look, and the quantity of x minus h by itself, so that's why we divided by 4. And so there's your final equation. So now, if you don't like the form, there's no harm in writing it as, x minus 1 equals, because then it matches a little better left to right side. For some of you, that is better for your brain. Go ahead and do it. All right, so with that, you should be able to look at this and say what your vertex is. Okay. Did you get a 1, -2? From there, you can look at 1/4 p. We've got 1/4 p coming from that number out front. And in this one, it's fairly basic. We've got 1/4 p, and p has to be a 1. So our p value has to be 1, which means our focus moves 1 to the right from where it was. Our directrix goes in the other direction, so it should have to go down. And the axis of symmetry is that y equals -2. So this is an example where we've got a horizontal line of symmetry, axis of symmetry, perpendicular to the directrix. And all they asked you to do was graph. From here, it's going to be very basic to graph. You have your equation set up. You can graph your key pieces, and that will allow you then to graph your other values that you would need to graph from. So that was a leading off x equals situation. I think this next one, now you're leading off with an x squared. So it's a y situation, which would be pretty normal. Up or down versus the one we just did, left or right, is your first gut feeling. So pretty similar. Isolate the terms, complete the square, simplify, factor that right side so that you just have a y value. Then move that term to the other side. And then from there, look at it. You should be able to see your vertex, HK. You should be able to calculate your p-value from the -1/6. From there, you can do your focus, directrix, and be ready to solve the rest. Once you have your vertex point, you know your axis of symmetry, so you should be on your way. Okay, so a lot there. We're spending 2 days on it. Really focus the first day on the ones centered at 0, 0, and then the second day, the translated ones. But be careful. Work on remembering, learning the different forms, memorizing those, where HK are, where the P is, where's your axis of symmetry, where's the directrix. A lot of stuff, definitely. So bring your questions and have those two problems as well.